Hi, in this video I want to talk about image stacking for astrophotography. This is a crucial step in the editing workflow for astrophotography for every kind of astrophotography. It could be starry landscape, star trails, deep sky images, or planetary work and lunar imaging. So the idea is to take many pictures of the same subject and then to stack them, average, and obtain a single image that is an improved signal to noise ratio. Now, to understand a bit, let's consider this scheme here. Here we have 12 exposure. You see you have some random noise. This is digital noise. And the idea is to sum all these images together. And remember, digital image is just a collection of pixels that they have a certain value. So we can add all the pixel values together and then average them in order to obtain a picture that is cleaner. So the random noise has been smoothed out and the real signal is therefore enhanced. And this is the only way you can reduce noise while boosting the details. There are no other digital method to avoid smearing details while you are removing the noise. Now, this is easy. And it is an easy case because, as you can see in the stack, our subject, the boat, is not moving. So for all the pixels in the stack that are defining the boat are always the same, so we have no problem in averaging all the image of the stack. Now, in astrophotography, this is not always the case. Even if you are tracking the sky, there is always some micrometric movement, sub-pixel movement between the pictures. And so you need to do something else. This is illustrated in this scheme here. You see the idea. Here we have three exposure that have a moving subject. And so you see that, for instance, the pixels that were recording the boat in the first image now are recording nothing but noise in the last and in the second to last images. So the result of sum and averaging all these picture as we did before is an image where the subject is mirrored out and is almost vanishing. This is pretty much the same concept that you have when you want to do long exposure of a busy square in order to free the landscape, the cityscape from the moving crowd. So the solution, as what we usually do in astrophotography, is before averaging all the images, is to align them to the subject. So in this way, when we go to average all the picture, like in this case, we have the subject that is always on the same position on the stack, and so we can reinforce the signal of the subject, remove the random noise, and what we need to do later is probably to trim a bit the edges because there was no perfect match until the edges of the different frames, because we have moved, translate and rotate the frames with respect to each other in order to align the target in the stack. So to show the advantage here, we can have a look at this image. This is a static image of a model of the lunar module from Lego. I took the single images that is here on the left. Those were taken with the Sony RX10, so it's a 1-inch sensor camera, and I boosted the ISO value to 6400. So you see it's very grainy. You have both luminance and you have chrominance noise. The good news is that this kind of noise is random, and you see that stacking to image already reduced the noise, and stacking 5 images it's even better, and I stack up to 30 images and you see how the image is clean. Now, of course, the averaging and the I didn't pre-aligned the shot, so there are some sub-pixel misalignment, and that create an image that is slightly softer for my taste, but um, we can just sharpen it, and we see how much the signal is improved, the image is clean, and this is a much sharper image than just what we produce from the stacking. If you want to compare a single exposure with the stacking, this is the case. I hope you can see the noise here on the dark part on the engine of the lamp. And here you have much less noise. Is a much cleaner image. You see here on the base the moon as well is very smooth. So I hope to make you understand how stacking is important for astrophotography. Now you can do image stacking with Photoshop. The idea is to load all the images as a frame in Photoshop and then try to align them. Photoshop is not exactly the best software to use for this work, because the auto alignment of the layers is a bit shaky when it comes to have images with low details and not strong contrast, so it may be difficult for the algorithm to find how the layer should be moved and translated and rotated in order to align them, for instance, all the stars in a deep sky image, and then to average them. So there are many software that we can use. If you are like me on a Mac, you are not in a big luck. You have some commercial software like Starry Landscape Stacker, Starry Sky Stacker. They allows you to quickly stack starry landscape and deep sky imaging. But other than that, you have to move to software like Astro Pixel Processor or PixInsight, Serial. Those are full-grown astrophotography package, except for Siri that is freeware. The other are commercial, and PixInsight is, of course, PixInsight is the best, is the king. Everybody says is where you want to go. It can produce pro-graded images, but is expensive, and the learning curve is very steep. So in this video, I want to concentrate myself on present some software that you can use for stacking. That is not difficult to use, and so if you are a beginner, it will ease your way into the editing for astrophotography. So since I'm already on the Mac, let's consider Starry Landscape Stacker. This is a very neat piece of software. What is asking now is to have to load the image, so we can go to Starry to the Starry Landscape folder where I have my raw file, and you can see here immediately the problem. In astrophotography, we tend to shoot in raw file to retain the maximum flexibility for editing the images, and Starry Landscape Stacker doesn't like raw files, so my Sony raw files are not read. So I will just quickly convert them into raw file, into TIFF file that are readable. So what I do, I select them. I prefer to move to and go directly to Photoshop, because anyway they are very few, are like 10 shots. What you may want to use the Adobe DNG converter. You can use raw therapy. You can use whatever you want in order to convert raw file into TIFF. I don't suggest you to convert raw file into JPEG, because JPEG is always a bit difficult to work with, is less flexible. So here we are in Adobe Camera Raw. I select all my images. Now I said save the image, and now I will save in the same location as a TIFF. Remember to put it is 16-bit. Don't resize, don't sharpen, just click save and let Adobe Camera Raw convert the format for you. So now it says 7 images remain. So should not take long. Of course, you can already see the problem if you want to align images with Photoshop. It can take a while in order to be able to load all the images as separate layer into Photoshop, and that's also another way why Photoshop is not the best way to do that. So now we are finished, and we can quit Photoshop, go back to Starry Landscape Stacker. You see now I have in my folder, I have the raw file and I have the TIFF, and we can organize them for kind of image. So we go back and we call again Starry Landscape Stacker, and now we can select all the TIFF file. Now this is very neat because what you have, in particular if you shoot from a fixed tripod, what you have the foreground here at the bottom that stays fixed, and you have the stars that moves during the sequence. So the idea is to separately align the foreground from the sky. And what Starry Landscape Stacker is doing is placing all this dot here as a point of alignment for the sky. You can add some dot, so you can add some dot here near the horizon, and you may find some dots that are on the foreground, so you can go with the erase tool. You can remove this one here on the van, or you can just simply paint and remove those that are very close to the horizon, or they cross and went to the foreground. So now we have the point to select the sky, and now we click on find the sky, and the Starry Landscape Stacker has used this information to create a mask for the sky. So the blue part is where the sky is for the software. We can paint here the sky to complete and improve the selection of the mask and refine the mask. We can go here. Now don't worry if you at this stage you cross, because you can paint back for the foreground and remove what you have selected, and you can adjust the brush size, and so this is pretty much what you want to do. So next is align with. Now by default Starry Landscape Stacker picks an image that is shown here, but you can select whatever image you want. So for this example I don't really care, so there is nothing else to do than just align and compose. You see it's very quickly is aligning all the images and is composing them, and what you see is that boom, the image is much cleaner. The foreground is not smeared. The stars are still dot of light, are not strike, or at least not more than what they are on the single image. So here you can choose between different ways to align and compose. You can play around and see which one you prefer. I found that the default one works pretty well, and then you can also adjust some brightness. You can zoom and see in detail the sky. You see how clean it is, this shot, and this strikes is because I was shooting from a fixed tripod, and that is consequences of not tracking the sky, even if I was using the 500 rules. So now this image has been taken with the Sony RX100 Mark II, so it's a pocketable camera with 1-inch sensor type. I was at 24mm f1.8, ISO 6400, and I shoot for 15 seconds, and I take 10 exposure because I wanted to stack in order to clean the image. So now that we are happy, we simply click on save. You can also save. You can say to save only the image, or you can also save copy for the image with a mask. So you will have a mask for the sky that you can use in Photoshop if you want to tweak this image separately for the foreground and the sky in a very precise way. So just save, and you will have the image saved in TIFF format, and that's everything for Starry Landscape Stacker. What you do next is to take your TIFF file, go to Photoshop or Lightroom or whatever software you like, and develop it. Now this software is commercial. It costs about $40 on the App Store and is available for Mac only. And but if you are interested in Starry Landscapes and you don't have access to a Windows computer or a Windows virtual machine, then this is a must-have software. From the same author there is Starry Sky Staker, and that is pretty much the same. I don't have it here on my computer because I use other software for that, but you can download it from the App Store. It is still commercial. It will cost pretty much the same, I think, and should be this easy to align and stack deep sky imaging, so imaging where there is only the sky and there is no the foreground. So this is one very nice piece of software you can use. Now if you are a Windows user or you have a Windows license and you want to take advantage of the much greater selection of software for beginners and free software in particular that is offered in the Windows environment, then I suggest you to install a VirtualBox and create a virtual machine with Windows. And this is my virtual machine with Windows 10, and here you can have a number. In Windows you can have a number of different software that are very good for stacking, and they are free, or they are freeware mostly, and are fairly easy to use. So we saw how we can stack Starry Landscapes in Mac using Starry Landscape Stacker. In Windows there is a different program that is called Sequator, and I want to show you how easy it is also to use this software. Now here is the interface for Sequator. It's very easy to understand. Here you have some basic command, and here you have some tweaks and settings you can do in order to affect what the program does with the image. Now you see here there are two red icons. Those are to turn green in order to be able to perform what the task you want to do. So the first thing is to load up the stars, the images. So I go in the directory where I have the same image you saw before, Starry Landscape. You see here I have my 10 images, and note that those are in raw format. So Sequator is able to read raw images, and this is a benefit. You don't have to convert those raw into the much heavier TIFF before you work on them, like you would do for Starry Landscape Stacker. So now we have the images, and he selected as a base image this one. I guess you can select whatever image you want. Just for sake of example, let's consider this one, and now we have another basic image. So all those shots will be aligned to this image there. Now you can say, you can even load some dark frame and flat frames. Those are used to remove noise that is fixed, like hot pixel and stuff, and vignetting. I don't have those calibration files with me, so we neglect that, and we give the output, let's say Stackert 2, and this is the name for the output, and we keep an uncompressed TIFF file. There it is. Now we have imported the image and told the program where we want them to go. So what we need to do with the program, we want to stack. So the first thing is to go in the composition, and okay, it's fine to have aligned the stars, and the accumulation, it's fine as a method, but what we need to do is to have freeze the foreground in a selective way. And then we can move. So you see now, when we froze the ground, we have this sky region area that is turned red, because of course we don't have sky everywhere. So what we need, you set a regular mask, and you see now on the image I have this cursor. I can change the shape with the mouse wheel, so increase or reduce the size of the brush, and then what we are going to do is paint where the sky is, pretty much like we did in Starry Landscape Stacker, only here you have to do it manually, completely manually. There is no a guess of where the sky is. Of course you can also delete your selection if you go a bit overboard. I think yes, it's the command on Mac, which could be the Alt key in Windows. So you see that I'm deleting the mask, so that allows you to refine the mask. Now we're pretty good with that. I don't want to. What you can do in this program is also to reduce light pollution, reduce the distortion effect, remove dynamic noise, set auto brightness. I don't really care about this for this example. You can play with this parameter and see whatever you want, how those affect the image. So now we are ready to click on start, and you see now what the program is doing. Is a bit slower than Starry Landscape Stacker, but that's also because you can make it do some tweaking along the way. You see here it says that in less than 2 minutes we should be able to have the final image, and I will pause this video and we'll come back when this is finished. Okay, so now is computing and integrating all the stack, is normalizing, is doing some correction, and now is completed. So we can close this, and the resulting image is loaded. I suppose you can maybe you can zoom. No, I don't see any way to zoom this file. This image, sorry. So anyway, you can see that it is quite clean. The image is a bit darker than what was with the Starry Landscape Stacker. The sky seems to be properly aligned, and the stars are as smaller as they are in the single exposure, and you have details of the Milky Way down until the horizon, basically. Now, of course, you can save this is already been saved in TIFF format, so you can import it to Photoshop and do all your tweaking, white balance, sharpening, and whatever you need to do. So this is how you can use Sequator in Windows. This is a free program, and over Starry Landscape Stacker it can read directly the raw file, and also it can be used to stack deep sky imaging and create star trails. Now I don't want to create star trails because I don't have the file here, but I will give you an example of how you can stack star field. So for this example we are going to load a different set of images that is here, and those are again raw file from my Olympus OMD camera. So now this, maybe you can see here, there is a hint of a nebula. This is the star field around the California nebula. It's 28 files. Each image is 3 minutes long, and was taken at f2.8 or f2 with Samyang 135mm at ISO 800. So again, we select the output, and yes, we can select the same of the test that I did before. Do you want to replace? Yes. And then we move to the option. So now accumulation stars is fine. You see the sky region is full area by default and is okay. You can leave auto brightness off. What is interesting is that you can reduce the light pollution. All the images do have some light pollution. Put deep sky, and I suggest you to reduce a bit to reduce the default strength of the filter, because, well, usually they tend to go overboard. So maybe we can also try this auto brightness. And so now we are ready to stack. So we just go we start the program. You see, as before, is composing, is loading the imaging, and is doing whatever he has to do to align the shot. Now consider that I was taking this photograph from using a Skywatcher Star Adventurer, so I was tracking the movement of the sky. So there is not much to do for aligning this, for aligning the star through the stack. If I was shooting from a fixed tripod, then even if I was using the 500 rules to have the stars sharp in each exposure, if I was photographing the sky for 1 hour, then, for instance, these stars here would have moved like here, and so would be more difficult to create a nice stack, and I would have to trim a lot of the edges. So it's all deep sky astrophotography. It's always better to do it with a tracking mount, at least with a star tracker, and in this way we can get the best chance for high quality imaging. So you see that it's going pretty fast. Before we had only 10 images, now we have 28, and this is because we don't have to separately align the sky and then recompose the image, and so this is one thing. So this is a very nice little software. It's particular for beginners. It can do it allows you to stack starry landscapes, deep sky imaging, and also create star trails. It can read directly the raw file, and the minus are that in few clicks, while in few clicks you can do everything, you lack a bit of control and advanced functions and algorithms to create a really nice stack or particular way. So you see now everything is successfully done. So we can close that, and this is the stacked image. You see the artifact on the edge. That is due to the original misalignment of the frame, but you also see that right after the stack, we now can see the California nebula in red, and so that is quite interesting, and this is the reason why we do stack. Now, if you are really into deep sky astrophotography, this limitation of Sequator are somehow troublesome, so there is a better program to do that. So we say hello to Sequator. I hope you have enjoyed this little moment with it, and if you are a beginner and you are on Windows, then this is something that you should have on your box tool. on your toolbox. So the next we want to use is Deep Sky Stacker. Now this Deep Sky Stacker is also known as DSS, is probably one of the most widely used software for stacking deep sky imaging, because it's freeware and it works relatively fast, has some advanced mode like comet mode stacking, and there's a lot of advanced method you can use. It can perform drizzle and things like that. And you have different algorithms that you can use to stack, and it can also calibrate your imaging with dark files, with flat files, with dark flat files, and with bias files. The software is very easy and intuitive to use. You have three main sections. We have this shoulder part here where you have all the commands. You can load the image, perform the stacking, save, tweak the parameters. Here you will have the list of the loaded image, and here you can see and here in the center part you can see the image. So the first thing to do is to load up all the image. We are going to load directly the raw file, of course. They appear here. Then if you move, you can also see now I think I will go full screen, so I can access this scroll bar, and to show you that here there is all the information you need about your image. Here is, of course, to declare that this is a light frame, and this is the resolution, that is a raw file, the ISO, the exposure time, and the aperture you have used for shooting the image. So all this information are there. I don't have calibration files, so I don't add those. And what I go to do next is to check all the image, so that will tell DSS to use all the image that has been loaded, and we go to register checked picture. Now, in this dialog box there are some information. First, this red part will turn green once you add all the calibration files, and there is here also the opportunity to say, okay, just create a stack with the best 75% of all the picture that has been loaded. So you can tune this. If you are very picky, you can lower this threshold. If your images are very good to begin with, you can stack all of the picture. Mind that this all of the picture is all the picture that are good. So things where there are planes passing by are removed directly from DSS. Are not considered for stacking from DSS, so they will not appear even if you set 100% of the picture. Now you want to go to the Advanced tab in order to compute, to have an estimation of the number of stars that the program can detect. Now here I have a small problem. It's not a problem, it's just a warning about the raw file from Olympus. It's not a problem. Now you see that with the threshold of 64%, I can detect 244 stars. If I go, I don't know, like 90%, the number of detected stars will probably be 0, because the threshold is too high. If I go like 13%, the number of stars detected will be insane. And both these extreme cases will create some problem. So the best is to have a number of detected stars that is around in between 200 and 400. Of course, if you are 200, if you are 400, the process will go a bit slower. Now, once you have said that, what you can do is to go to recommended setting. Here, depending on what you have loaded into the program, there are some suggested settings. Here there were two possibilities. I just choose one. You can experiment with these parameters. So usually default parameters are pretty good in DSS, so you don't need to do much more. In stacking parameter, you can access all the different properties and methods to align and stack the light frame. for now what you want to have is that standard mode is selected, click OK, then click OK again, and now you see here is a summary. You have a stacking mode that is standard, the alignment method is automatic. These are the parameters for the stacking of the 28 frames. That gives you an exposure time, a total exposure time for the sky of 1 hour 24 minutes if all of the image have been considered. And this also is the amount of space that this program will need on your hard drive, and this is how much space you have available. So we are ready to go. We click OK, and now the first part is to register all the pictures, and then to stack, to compute the final pictures, and then to load it. So this is the elapsed time, the estimated time for the registering. It is a bit slower than Sequator, but it will produce a better stack to work with. So I will pause the video, and as usual we'll see each other later. Okay, we are back. The stack is finished, and now DSS is computing the final picture with the parameter that with the method we selected before. And so then when this is finished, it will save an autosave file in a TIFF format. You see here that is doing the autosave, and this TIFF file is 32-bit, and I suggest you to manually save your file as a TIFF of 16-bit instead, so make it easier to work with certain program. Photoshop can load 32-bit files, TIFF files, but then you need to move to 16-bit to convert them to 16-bit in order to really access all the functionality of Photoshop. Now is loading the picture, and you can see that the picture looks very washed out, and this is because some settings have been applied by default from DSS. So you can see here there is a curve, a S-shaped curve, and this is pretty much the same curve that you use in Photoshop, the curve tools. And here you see the histogram from the different channels, the blue, the green, and the red. So just to give you an idea, if you want to tweak a bit the image in Photoshop, we can move and realign these peaks for the different channel where you want. We can tweak the shape of the curve and do something like this. And we can apply, and then you see that the image is much darker now. What I want to point out is that DSS is not really done for this kind of work, so the best thing is just save the picture to file as a TIFF, 16-bit TIFF. We can call it stacked 2, and importantly, just get the stacked image and without apply any of these settings, so just embed them but do not apply to the image. Save it, and now you can quit DSS, and then you can move directly to Photoshop with this TIFF. Here you see that it takes 95 megabyte, while the 32-bit version is 130. So that is a bit the effect of having 32-bit is increase the size of the file. Now, before going on, I want just to show what this TIFF looks like, because that could be worrisome for you. Because you will see that it's very dark, and that is where you need to do. You see, it's very dark, there are no details whatsoever. So what you need to do is the other crucial step in the astrophotography editing workflow, that is stretching the histogram, and this is all another topic that we'll cover in another video. But so if you end up with an image like that, do not worry, all the data are there, are just hiding in the dark, in the background of the sky, and we need to do the histogram stretching in order to make them going out. Okay, so in this video we have already seen how we can stack starry landscapes and deep sky imaging. The other big category of astrophotography is planetary photography and moon photography. And again, if you are a Mac user, you are not in luck, because there is only Serial that has some support for that, and Linkeos. The best is of the free, at least, and easy to use software is in Windows and is Autostakkert. So here are shot of my moon. This is a raw file, so I will open with this. So that's the kind of image I want to stack in order to improve the details of the lunar surface. Before moving to Autostakkert, most of the time those planetary imaging need to be pre-processed using this PIPP software that is pre-process planetary imaging pre-processing. Is freeware, and it allows you to create videos from the raw file and to center the planet in the frame, crop the frame, and things like that. So also because Autostakkert does not open directly the raw file, so I use this application to convert my raw file into a video. And I will go into open video in Autostakkert, which is, as I said, is a free software. Now let me go full screen. Now you see that the interface is split in two windows. We have the main control window here, and here is where the image will be loaded. And while the interface is, to me, a bit confusing, the workflow is rather intuitive, because we have numbers. So the first step is to open the image. So by default is looking for a video format. So we go to desktop, where I have the moon. This is the directory that has been created by planetary imaging pre-processing, and that's the video file. So we load up the video file, and now if I zoom out completely, you should be able to see the moon. That is the red part is how much the moved during the video. I didn't align those imaging. So next, here you can this is the method is the planetary method to stabilize the image. We are not looking for lunar detail of the surface. Leave that. This you can leave by default. So the second step is to analyze the frame. So that is, we'll analyze the frame and order them per quality, and then you can decide how many of those you can stack. Now for this example we will leave everything by default, but you can play with the different parameters. So here you have the process bar, where you see where we are in the step, and this is the kind of task that is doing. So when this is finished, we can choose how the portion of the image to use to create the stack. So that is about the 50%, the best 50% frame. So this graph show the quality of the frame. This is the 50% threshold. You can go 75% and you will stack the frame here, and then this is how the quality degrade. I think I fairly it is a bit convoluted, this graph, so I usually don't use that. I just leave 50% or 75%. That I may have read it wrong. I need to check that. This is, you can normalize the imaging during the stack to 75%. You can do RGB alignment that could improve to have the chromatic aberration you may have along the edges. You can give a stack name or whatever. Now the important is that you cannot yet stack because you don't have points that are used for aligning the image. So you go now on this window and you can select the size of this point, and you can say, okay, place automatically a grid. Now you see how many points have been created. That's way too much. So I just go with a very large point, alignment point, and I try again to place the grid. What I want is to have something about 40 points, something like that. Now it seems that we have quite a lot of points also. So yeah, we have quite a lot. What we can do is to clear them and to manually draw some point of interest. You have to play a bit with this method. You want the point of alignment to overlap. So about something like this. You don't want to have too many. Maybe here, a bit along the edge, something like that. Okay, and then we can try to stack and see what is the result. Now you see that again we have the bar, the progressing bar, showing the progress, and then we are calculating, well, these are the different steps. There is to get the reference image, there is the alignment of the image, the stack, and the other tasks, and this is how long each task has taken. Okay, so everything is finished, and now we can go to see what is the result of this stacking. You find this in the original, in a subdirectory of the original images or video that you have load, and this is the stacked image. It's still it looks a bit soft. Autostakkert does not offer wavelet sharpening, which is a very much interesting way of sharpening this kind of imaging, but it offers some more advanced setting like drizzle, and it can be used for lunar surface details and stuff like that. So this is how you can simply stack the images with Autostakkert for a planetary and lunar shot. We could move then this TIFF to Photoshop and have it sharpen, or we can try to, I have here Astra Image, that is a software for high-end, let's say, editing for scientific use of imaging. But here, for instance, you have the wavelet sharpening, so I want just to show how things can change. So if we go enhance, and we can have a wavelet sharpening, and then is trying to calculate something, the parameters, standard parameters for the image. So we can try to sharpen and see. There is no preview, So don't go too overboard with the setting, because otherwise you will create artifacts. You see already that this part has been sharpened better. You can do other stuff like multi-scale sharpening. This has a preview. Now probably this is set on. I don't use this project, this program that much. Let's say here around the plateau, as a crater plateau, this one. So we can try to have some previews, and then you can selectively sharp the different part of the image, the medium details, the small details, the large detail, and so you can play with the image once you have stacked it. So, and this is pretty much the last step, and yeah, you see now the image is much sharper. So you can this is a commercial software, but you can pretty much do a basic sharpening with Photoshop as well. So you don't really need Astra image, particularly if you are not too much into astrophotography or lunar and planetary astrophotography. So I hope in this video I was able to show you how we can quickly stack images using free software that are quite easy to use and intuitive, and also that to convince you that stacking is the way to go for astrophotography imaging. And that's why when you are out and about in the field, you should shoot keeping in mind that you will stack your image later. So just not take a single picture and pack it up and go home. Stay in the field, take as many pictures as you can, and then once at home, stack them to get a great basic image to start editing. And with that, I thank you for watching, and in the next video we'll probably talk about histogram stretching for deep sky astrophotography. Bye.